Welcome to the ITFreeTraining video on the OSI model. This video will look at the OSI model and in particular how it relates to the Internet Protocol. The OSI model was first developed in the 1980s. It is a conceptual model aimed at standardizing network communications. The model is not implemented in its entirety, but it is still referenced today. As shown, the OSI model has 7 different layers. Each layer is directly linked to the layer above and below it if a layer exists. As data travels down the OSI model, each layer adds additional information. This continues until it reaches the last layer. It is then transmitted across the network. Once the other side receives the data, the process is reversed. You can see how each layer requires the layer or layers adjacent to it. Also, it's not possible to skip a layer. All communication either starts at the top layer or is received at the bottom layer. So, what does each layer of the OSI model do? At the top is the application layer. This layer provides the application programming interface. The next layer, presentation, is responsible for data formatting. This includes encoding, encryption, and compression. The next layer, session, is responsible for connecting and reconnection of the network connection if it is lost. This also includes authentication of the connection. The next layer, transport, manages packet size and the resending of data if it is lost or corrupt. The following layer, network, routes data between different nodes in the network. The second to last layer, data link, is responsible for flow and error control. For example, ensuring more data is not sent out than the local network can handle. The last layer, physical, communicates directly with the network and is responsible for transmitting data on the network. As stated, the OSI model is a conceptual model and not directly implemented in modern networking, but it is referenced from time to time. To demonstrate this, I will now compare it to the TCP model. TCP stands for Transmission Control Protocol, and IP, as we know, stands for Internet Protocol. A number of protocols are used to make Internet communication possible. These protocols are grouped together under the name TCP/IP. Nowadays, you don't hear this name so much. Generally, you will just hear IP4 or IP6, but it is still valid. As you can see, TCP/IP has 4 different layers as opposed to the 7 layers of the OSI model. It is shown as an exact fit. However, in reality, it does not fit the original OSI model exactly. The application layer maps to the first to third layers of the OSI model. Transport is a direct one-to-one mapping. The Internet layer maps directly to the network layer, and the last 2 layers of the OSI model map to the network access layer. Even though there are only 4 layers, each layer can be broken down further. As seen here, at the application layer is a number of different protocols. You can see how software will generally use protocols to access services on the Internet. The protocols themselves will access the transport layer. At this layer, there is a choice of TCP and UDP. TCP stands for Transmission Control Protocol. TCP gives reliable transmissions. If a packet is lost in transmission, the protocol will notice it has not arrived and request a resend. In contrast, UDP, which stands for User Datagram Protocol, is unreliable transmission. If a packet goes missing in transit, it is not resent. Think of UDP like mailing a letter. Once you mail the letter, you have no idea if it will arrive at its destination. The next layer determines if IP4 or IP6 is used. At the bottom is the device driver, which communicates with the network. The most common type is Ethernet. However, any other network device is supported. You can see how TCP/IP is very modular. This makes it easy to add additional protocols and add additional hardware when they are developed. I will now have a look at how the OSI model may get referenced today. The first device I will look at is a Layer 1 device. Remember that the OSI model refers to the first layer as physical and controls the transmissions at the bit level. Examples of Layer 1 devices are repeaters and media converters. A repeater essentially extends the limits of a network by boosting or recreating the network signal. A media converter, like the one shown, converts a particular network type to a different type. In this case, the media converter converts a fiber signal to an Ethernet signal. Layer 1 devices are very simple devices. The next layer I will look at is the data link layer. This performs flow and error control on the physical link. Examples of these are switches and bridges. Switches, like the one shown, allow multiple devices to be connected together on the same network. They differ from Layer 1 devices in that they can perform some management of that data that goes through them. For example, if a packet is sent to the switch, the packet will only be sent to the port that contains the device that packet is destined for. Layer 1 devices, in contrast, simply repeat the data that comes in from one port and replicate it out the other port. A bridge is a Layer 2 device that connects two networks together. For example, connects wireless to wired network. It is different from a media converter in that it inspects the data before sending it. For example, data that does not need to be sent to the wireless won't be. In contrast, a Layer 1 device will repeat everything that is transmitted to it. Next, I will look at Layer 3 devices. These devices work on the network layer of the OSI model. Layer 3 devices have the ability to route traffic between networks, so routers are considered Layer 3 devices. Also, certain switches have the ability to support routing. Shown here is an example of such a switch. It looks just like a regular switch, except it has routing ability. The advantage of using such a device is since the routing is performed in hardware, it is quite fast. The last layers that I will look at are 4 to 7. Usually, hardware manufacturers don't sell devices marketed under these layers. Which device fits in which layer tends to be a bit blurry. Devices that are considered Layer 4 switching tend to be Layer 3 switching devices with more features. The term Layer 4 switching does not tend to get used that much. Essentially, it means that the devices can route traffic based on what type of traffic it is. In many cases, this is used to prioritize certain traffic over other traffic, for example, routing web traffic before video traffic. Layer 7 devices tend to be devices that can inspect protocols. For example, they can inspect HTTP. For example, some firewalls are considered Layer 7 devices since they can inspect packets at the protocol level for certain types of attacks. Most applications work at Layer 7. For example, an email server. As I said, devices don't tend to be marketed using these levels, so it is more having an understanding of which level the device may fit best. That covers it for this video of the OSI and TCP models. I hope you found this video useful. For more videos, please see our YouTube channel or webpage. Until the next video, thanks for watching.